You look at a rocket launching and think, wow, that has to be incredibly complicated. But what if I told you the basic idea, the secret that gets that massive ship off the ground, is actually super simple? Let's get into it.
Okay, so first things first, let's make sure we're all on the same page. Because, the word rocket actually means more than you might think.
So let me ask you, when I say the word rocket, what's the very first thing that pops into your head? Go ahead, get a picture in your mind. You got it? Okay, hang on to that image. Did you picture a flower? Yeah, I'm serious. For some people, especially gardeners, a rocket is a plant with these really beautiful flame red flowers. Kind of throws you for a loop, right? Now, for a lot of us, it's probably this New Year's Eve, a celebration. You see those fireworks lighting up the whole sky, that big burst of light and sound. Okay, now we're getting a lot closer. And of course, this is what we're really here to talk about. The big one, the massive spacecraft that travels to the stars. This is the rocket that captures our imagination. So let's figure out how these incredible systems actually work. So you've got this gigantic machine weighing thousands of tons. How in the world does it even lift off the ground? Well, the secret is all about a push. A really, really big push. And it's simpler than you might think. And here's the crazy part. Believe it or not, a modern spacecraft, this incredible feat of engineering, is really just a much, much more complex and powerful version of a firework. Yep, that's the core idea. And the science behind it, it's been around for ages. We're talking about 300 years ago, figured out by none other than Sir Isaac Newton. It's his famous third law of motion. And get this, the same rule that explains how a rocket gets to Mars also explains why a balloon flies all over the room when you let it go. Pretty cool, huh? The law basically says this. For every push in one direction, there's an equal push in the opposite direction. So think about it. The rocket blasts super hot gas downwards with a ton of force. And what happens? The universe pushes back. An equal force pushes the rocket upwards. That's the whole secret. Push down, go up. Simple as that. All right, so we've got the big push idea down. But what's actually making that push happen? Well, a rocket isn't just one thing. It's a whole system. It's like a recipe for creating a massive amount of energy. And that recipe has 3 basic steps. You start with your input. That's all the potential energy just packed into the rocket's fuel. Then comes the process. You burn that fuel, which turns it into a crazy amount of expanding hot gas. And finally, you get the output. That hot gas shoots down, and that's the powerful push that sends the rocket soaring up. Okay, but here's where things get really interesting. This is what makes a rocket totally different from, say, a car or a plane. It has to solve a huge problem, the space challenge. Think about an airplane engine. It needs to breathe air, just like we do. It sucks in oxygen from the atmosphere to burn its fuel. But once you get up to about 25 kilometers, the air gets really, really thin. There's basically no oxygen to breathe, so a plane engine just stops working. A rocket, though, it's special. It's like a deep-sea diver. It brings its own oxygen tank. That's the game changer that lets it fly in the total vacuum of space. So we've built this amazing machine. It can create its own massive push. It can even bring its own air to breathe in space. But why go to all that trouble? What's the whole point? Well, the whole reason a rocket exists is to carry something called a payload. And that's just a fancy word for the important cargo. We're talking about people, astronauts, or the satellites that give us GPS and internet, or even robotic rovers that we send to explore planets like Mars. That's the precious cargo. And just stop and think for a second about what this simple system, this idea of a big push, has let us accomplish. We've used it to land humans on the moon. We've sent robotic explorers to drive around on the surface of Mars. It's gone from a simple firework to all of that. It's absolutely incredible when you think about it. So, the basic principle is simple, but the potential, well, it's limitless. We've gone from the ground to the moon and beyond. The only question left is, where to next?